Hi, and welcome to Career Bites. My name is Amelia Sullivan, and I'm here at NASA's Langley Research Center with Bob Tolson, who is a professor at NC State, and he's a NASA Langley professor. Thank you for being with us today. So tell us how you were involved with the historical Viking mission.
Well, let me back up a little bit. Let me go back to Lunar Orbiter.
Okay.
That was my first mission. It was 4 years after I got here, after I graduated from Virginia Tech. And once you're involved in a mission like this, the adrenaline gets so high that the adrenaline high lasts for maybe 30 or 40 years.
Yeah.
Okay, so you got to keep involved in missions. So after Lunar Orbiter ended, 3 or 4 years later, Viking got started. And so I had to get involved in Viking. So I went over to the Viking Project in 1969 just to pump my adrenaline back up a little bit.
So tell us, you're a professor at NC State University, and your official title is a Langley professor. So tell us what exactly, as a Langley professor, what you do and how your students are using data from Mars and space data.
The Langley professorship, there's 6 Langley professors. We're at the National Institute of Aerospace. There's 6 local schools that support the institute. And the Langley's professors cover a broad range of activities. The one I'm most interested in, of course, is space. We get students from all the schools, and they come here and get their education right here on the peninsula. And they work inside the fence with NASA mentors. Having been involved in space missions, I've been trying to keep students involved. When I retired from NASA Langley, I went to George Washington University and tried to stay involved in space missions there. And we've had students involved in the Magellan mission at Venus, in which one of the students actually, for his master's thesis, actually burned up the spacecraft. That was intentional. It was called the termination experiment. We were doing atmospheric measurements while it was being terminated. And then from that mission we went to Mars Global Surveyor, and we did aerobraking, in which the spacecraft continually dips into the atmosphere, just a little bit of drag, not so much to burn it up, but just enough to change the orbit. And that lasted for 2 years. We had a team of about 8 or 10 students doing that. From that mission we went to Mars Odyssey 3 years later. We again did aerobraking. And right now I have a team of 7 students who, as we are speaking, are analyzing data that came down from Mars about 6 o'clock this morning. And they'll be reporting, since I'm not going to be available today, they'll be reporting to the project manager on what the state of the Mars atmosphere is today. In other words, they're giving a weather report on what's happening in Mars' upper atmosphere at 2 o'clock this afternoon.
So back to the Viking mission, explain why you think that mission in particular was so groundbreaking and so successful.
Well, it was the first.
Yeah.
It was the first spacecraft to land successfully and be able to perform science experiments on another planet. And a planet that could in fact support life. The moon could not support life. And of course this was after the landing on the moon, but still there's no way for life to be on the moon. But here's a place where there's a very high probability that one time there were probably very simple organisms with life forms on Mars. So very critical from that standpoint. And I think it changed our focus too, from things like the moon and the Earth to this distant planet. And it was like when we went to the moon and we got the picture of the Earth from the first time from the moon. And that changed our whole perspective of who we are and where we live. And I think Mars did the same thing. Here's another place we can go to. It's similar to what we have here, but it just gives you a different view of who we are and where we live in this wonderful place we're saturated in.
Yeah. So would you consider planetary research or space exploration a good career path for today's young people who are looking for different fields to get into?
Yeah, but I would say, I would broaden out a little bit and say space in general is just an exciting place to be because it's different every time you go someplace. Every planet is different, and every time we go somewhere we're surprised. That's part of the excitement of it because you're working with the unknown. I mean, you've heard some of the talks today talking about all of the things we knew before we landed on Mars, all the data we had, but when we got there we found out it was different. It's every one of these aerobraking missions we've done with students, every time we go it's different. we take our previous experience, we develop models based on that, we do predictions on what the next mission is going to be like, and when we get there, Mars ain't the way we planned for it to be. Okay, so it's exploring the unknown. Okay.
Yeah. So what was the feeling seconds before the Viking landed, going back to the Viking mission? What did you personally feel like before it landed and then when it did land?
I was sitting right out here in this auditorium when the spacecraft landed, and they had a big screen up here, maybe the same one they have today.
Mm-hmm.
And they started showing the first picture as it came back from the camera, real time, right straight from Mars. Okay, and the camera scans from the top to the bottom of the screen, and you could see it was scanning. It was like watching snow on your TV set. Okay, you could see the scan lines going down. It slowly filled up the screen. They were just snow, nothing but snow. And then there was scan lines. You could tell it wasn't quite snow, had some structure to it. Then the next scan line filled that in. And pretty soon, with maybe that many scan lines across that big screen, you could see you were on Mars. There's Mars, right? So you turn around and look to people. And there was, nobody had been breathing for about 15, 20 seconds while these things were happening. You turn around, there's not a dry eye in the place. That's why you do it.
Yeah, that feeling.
Yes, nothing like it.
So President Bush has called for putting a lunar base on the moon and human exploration of Mars. Are there any other projects that you would like to see happen or you think are just as important?
That's a tough one. I think that's an excellent goal. I think it's a great stake to drive in the ground and say this is something we want to do in 20 or 30 or 40 years, and then put the program together to get there. The unfortunate thing, of course, is this is such a political society. The chances of something like that surviving for more than a decade is very unlikely. So it's very unfortunate that we can't actually set goals like that and maintain them. This society just can't do that.
Do you think, you were talking about before the virtual reality being so revolutionary with technology, do you think then it would be necessary to send a human to Mars, or do you think virtual reality would be just as fine?
Well, the project scientists for the Mir spacecraft, Spirit and Opportunity, who've been there, and they were supposed to last 30 days, 60 days, 90 days, something like that. Have now been there for a year, 2 years actually. Landed in January of 2004. 2.5 years, one Martian year, more than a Martian year. The project scientist was asked, Steve Squires was asked, what could humans do that these Mir spacecraft couldn't do after they'd been there for a Martian year? He said a trained geologist could have discovered everything that these guys have discovered in 15 minutes.
Wow.
Yeah.
So
Nothing like the old brain.
Yeah, so it's worth it. So finally, do you have any advice for today's young people who are looking at space as being a possible field?
Yeah, I mean, it's a good thing, but I think the most important thing is to consider the most important word in your vocabulary is why. Why?
And that could
And
apply
it applies to everything.
Yeah.
Why? Why when I'm sitting in a stoplight does that light tower, does the traffic light sign move like this? What's happening to those bolts that are holding it in place? Why does a 18-wheeler built the way it is? These are simple questions, but you're sitting at a stoplight, you don't have much to do. Right?
Yeah.
Think about it. Why? Just keep that right out in front of you.
Okay.
And then space, aeronautics, engineering, energy, whatever. That's the easy part of it. It's always fun. If you keep why out there, it'll be fun.
Okay, well, thank you for sitting down and talking to us today. I'm Amelia Sullivan, and we'll see you next time on Career Bites.